Hello there. In this video, we'll be looking at how to construct the formula of a quadratic function by studying the graph of the quadratic function. Now, to be able to construct the graph of a quadratic function from its graph, there are two major informations that we need. Now, the very first information that we need is the vertex of the graph, and the other information that we need is the coordinate of another point that passes through, or another point that the graph passes through. That is the coordinate of another point on the graph. Now, looking at the graph that we have here, the very first point, or the coordinate of the vertex which we are given, is 2, 1, and then another point through which the graph passes through is the point 0, 5. So I've been given my vertex. My vertex is 2, 1, and then another point on the graph is 0, 5. Now, how do I use these two informations that I'm given to construct the quadratic the formula of the quadratic function? Now, something is going to come in very, very handy here, and that is if you're given a function f of x equals, so we know this is the general formula for a quadratic function, ax squared plus bx plus c, that has a degree of 2. Now, any quadratic function with vertex that has a vertex which coordinates h comma k now can be written as, so you have f of x equals, so your a still stays, so you write a into x minus h all squared, then plus k. So anytime you have a quadratic function and then you have an idea of the coordinate of the vertex, now another way of writing the quadratic function is by writing it like this. So anyway, we're given a vertex, the coordinate of the vertex to be 2, 1. So our vertex is 2, 1, and then when you compare it, this is my h, this is my k here. So I'm going to substitute the h and k values here into this general formula here. So what I'm going to obtain is f of x equals, so you have a into x minus, now my h here is 2, so that's going to be 2 all squared, then plus my k here is 1. So I'm going to expand that. So when I expand this is what I obtain. You have f of x equals, so it's going to be a into x minus 2 all squared, so this is x minus, this is going to be x squared minus 4x plus 4, then plus 1. This is what we have. And then we are also told that another point on the graph is 0, 5. So 0, 5 is another point on the graph. Now, an interpretation of this coordinate is that when x is 0, then f of 0 is 5. That's exactly what this means. So let's see how I'm going to implement this here. So it says f of 0, so when x is 0, f of 0 equals, so a into now 0 squared minus 4 times 0, that's 0, then 4 times 0, that's 0, plus 4, then plus 1. So this is going to give us a into 4 plus 1, that is 4a plus 1. So this is f of 0 equals 4a plus 1, and then from here we have f of 0 equals 5, so this should be equal to 5. So if 4a plus 1 equals 5, so we could subtract negative 1 from both sides, so we have 4a equals 5 negative 1, and then you have 4a equals 4, and then to find the value of a, we divide both sides by 4, and then this goes off, so you have your a to be equal to 1. So now I've gotten a value for my a, so I could just write this as, you have f of x equals, so my a is 1, so that's going to be 1 into, you have x squared minus 4x plus 4 then plus 1, and the same thing as x squared minus 4x plus 4 plus 1, and then this is going to give you x squared minus 4x now plus 4 plus 1, that is 5. So f of x equals x squared negative 4x plus 5. So we have been able to construct the quadratic formula of the graph that we're given here. So you should note again, when I constructed this, all I used was a vertex and another point on the graph, and then that completes the problem. Thank you for watching.